So now that we've talked about the distance, let's talk about midpoint. So easy things. What's the middle number between 2 and 17? Well, I can easily find that by saying, well, 2 plus 17 over 2. And that's going to give me 19 over 2. There's the middle number. That works for any two numbers. Negative 4 plus 27 over 2. So that's 23 over 2. There's the middle number. Okay, this one, 165 over 2. There's the middle number. Since that works with any two numbers, it also works with coordinates. When I look at a problem like this, where I want to find the endpoint, here's the endpoints, I want the midpoint between them. So negative 3, 7, and 7, 1. I want the point that's in the middle of that segment. So I'm going to do the same idea. I'm going to find my middle x. So that's negative 3 plus 7 over 2. Negative 3 and 7 is 4. So that gives me 2. If I want the middle y, I'll take 1 and 7. 1 plus 7 over 2, which gives me 8 over 2, which gives me 4. So my midpoint, I'll call it capital M, middle x of 2, middle y of 4. And if we plot that, what do you know? It looks like it's pretty close to the middle of my segment there. So let's break that down into a more abstract form. We're just looking for the middle of the two x values, the middle of the two y values. So when it's an abstract form like this and I want this midpoint, basically, I'm going to say my midpoint is equal to the middle of my x values. So add the x values up and divide by 2. And the middle of the y values. Add them up, divide by 2. Remember to put a comma in between and keep it in parentheses. This is an ordered pair. So that's all you got to do for midpoint. It's a very, very simple formula. Let's look at an example of a midpoint problem, and we'll go from there. So here's our problem. I want the midpoint of that segment. I'm going to add up my x's, so negative 4 plus 2 over 2, and add up my y's. 6 plus a negative 3 is minus 3. So negative 4 plus 2 is negative 2 over 2. 6 minus 3 is 3 over 2. So my midpoint is the point negative 1, 3/2. Okay, you're going to try the next two problems. Okay, see how you do on those. Play with your fractions here. Leave things in fraction form. Okay, reduced fraction form is always better. But I do want to show you one more type of problem before I let you try some. This point's one is a little different because this time they tell me the midpoint of the segment. So we've got to look out for that. I know one endpoint. So I'm going to set up my formula. My midpoint is 3, 7. If I use my formula for that, then I add up my x's. Well, one of my x's is negative 4, but I don't know the other one. One of my y's is 8, but I don't know the other one. These 2 points should be the same. 3, 7, and this should be exactly the same thing. So that means this part should equal 3, and that part should equal 7. So there's 2 equations I can set up. 3 should equal the negative 4 plus x over 2, and 7 should equal 8 plus y over 2. So we just need to solve for each variable separately. When I cross multiply, I get that, and I add the 4 to both sides. There's my x value. Same thing, cross multiply, subtract 8 on both sides. I believe that gives me 6. And now I have my x and y values. We do want to find the endpoint, so make sure to put this as a coordinate. My coordinate is 10, 6. So you're going to try one of those too. Okay, so try and find those midpoints and then find the endpoint. After this is all said and done, there will be a delta math. Ignore that date. We're going to make this one due. Actually, you know what? We will keep that due on about the 16th or so. Okay, so that'll give us some practice. Not too bad. It's a few problems on both midpoint and distance. Go for it.